benzaldehyde. So here we have the two structures that will be reacting, which is the benzaldehyde and ethyl glycol in the presence of an acid. And that's why we have this H plot here to indicate that it's in acid conditions. All right, so this reactants will be producing an acetal, which will be later on discussed. So let's jump into the mechanism of this reaction. Okay, so the first step of the mechanism is the protonation of the oxygen in the benzaldehyde, which can be seen from the pair of electrons attacking the hydrogen. Since, again, this is an acidic solution, and it will give this structure to your right here. In step two now, we have here our protonated benzaldehyde, which is more electrophilic. We also have a oxygen element attached to the carbon, and this causes the an electron pull more to the oxygen, which makes the carbonyl there to be more electrophilic. And so we have our nucleophile, which is our ethylene glycol, that will be attacking the pi star at our carbonyl. This will cause the break of the double bond here, and the pair of electrons of the double bonds will now move forward and upwards to the oxygen. That will cause the formation of the tetrahedral intermediate here to our right. In step three now, we have here our tetrahedral intermediate. Um, And also, let's recall that this is an acidic solution. And in order for us to go forward to our desired product, to the formation of the acetal, we need for the hydroxyl group up there to actually leave. And let's recall that to make a good leaving group, we need to protonate it. And that's why I have drawn that arrow there, um, causing the protonation of that hydroxyl group. And that will be forming water, which is an excellent leaving group. In step four now, we still have here our tetrahedral intermediate along with our good living group up there, which is water. And the main thing that happens in this step is the collapsation of the molecule. So the molecule collapses, so it forms that pi bond within between the oxygen and the carbon there, and that causes the water to leave. And I have labeled the arrows there as 1 and 2 to see what happens first and after. And so it gives us this molecule to our right. In step five, now we have our system here to our left with a double bond, which is that what caused the water to leave. And this caused the carbonyl to become a good electrophile. So now we'll have the intramolecular interaction of the hydroxyl coming and attacking the carbonyl, the pi star there. This is somewhat related to the second step of this mechanism. And this will cause the formation of our system here to our right, a five-membered ring with an alcohol in the ring. And our final step to this mechanism is the deprotonation of our system. So here in step six, as you can see to our left, we can note that there is still a hydroxyl group attached to our five-membered ring. And so we need to deprotonate this. And so we can use the same water that was eliminated in step four to remove the hydrogen. And so the pair of electrons will go back to the oxygen. That's the second arrow there. And then it will be forming our final product, which is the acetal, which of course is more stable. And here we have the overall mechanism of the reaction. At the beginning, you can see that we have our benzaldehyde in our acidic environment, which is representative by the H plus. So it gets protonated because of the acid. Secondly, we can see that our nucleophile attacks our electrophile at the carbonyl, at the pi star, which causes the pi bond to break. And so the pair of electron goes back to the oxygen. Thirdly, there's again a protonation of the hydroxyl group there to form water, to of course make it a good leaving group, which can be seen in step four. In step four, basically the molecule collapses so that the leaving groups leaves, of course, and it forms a double bond between the oxygen and the carbon. And our fifth step, you can see that there's a intramolecular interaction with the hydroxyl group up there, which attacks the carbonyl, same related to the second step of the mechanism. So it causes the double bond to break and it forms this five-membered ring. However, it still has that hydroxyl group there, which later is deprotonated by the same water that left in step four, and so it causes our final product to form, which is the acetal formation.